All right. Hi, everybody. Happy Monday. So last week we talked about multiplying and adding rational functions. So today we're going to talk about adding and subtracting rational functions. So remember, when you're adding and subtracting, the main key when you're adding or subtracting fractions is that you're going to need a common denominator. Right? So let me remind you how we, at the beginning of the year, talked about adding fractions. So for example, if we had 2/3 plus 1/5, do an easy one. I had you put in equals, draw your line across. I had you put your common denominator over here. And then I said, okay, what are we multiplying the first factor by? So we put 2 times 5 here. And then whatever our middle process was, and then we multiplied whatever was missing over here. So I had 1, and then it's missing the factor of 3. And then we simplified. So we have 10 plus 3. So we got 13 over 15. So today we're just going to add some variables in and have a lot of fun with it. All right, so here we go. Let's talk about the steps I want you to think about. So step number 1. I want you to factor everywhere. That should sound familiar. That's what we did last week. Step 2, I want you to state your restrictions. And remember, restrictions are what makes the denominator 0. 3, I want you to find a common denominator. Step 4, I want you to multiply each fraction by what I call the missing factor. And then step 5, we're going to simplify. Sounds pretty easy, right? Let's talk about it. Here we go. We're going to start off with a really, really easy example. Here's example number 1. On example number 1, we have 1 over 4x plus 1 over 4x. We just happen to have a common denominator already. So we have a 4x is our common denominator. Our restriction, what makes this denominator 0? We can say that x cannot equal 0, right? It's the only thing that will make it 0. And then on the top, we would have a 1 plus 1. So since there's no missing factor here and no missing factor here, we end up with 2 over 4x. Well, what do you see? We can actually reduce 2 over 4, so it's actually 1 over 2x. Again, with that same restriction. Let's try another one just a touch harder. I know how you like it when I say that. Here's example number 2. Let's go with 3 over x minus 1 over x. Alright, so everything factored, if you think about our steps. Step 2, state your restrictions. Well, x in this case cannot equal 0. Alright, common denominator. So I put my equals and draw a line across. Common denominator here is x. Is this one missing a factor? No, it has all of them. So this is 3. My middle process is minus. How about this one? Is this factor or denominator missing anything? It's not, so I'm just going to put my 1. So on top I have 3 minus 1. And on the bottom I've already got a common denominator. It's done its job, so I'm just rewriting x. Alright, we're going to step it up even more. Here's example number 3. Alright, let's say I have 3y plus 4 over x squared y plus x minus 1 over 2xy. All right. So you can see we're starting to get a little bit tougher. Oops, a little too far. There we go. Sorry about that. All right. So factor everywhere. It is all factored. State your restrictions. Let's start with x. What's the only thing that x cannot equal here to make the denominator 0? Can't equal 0. What about y? We have another variable y here. What can y not equal? It cannot equal 0. All right. So now we move to getting that common denominator. Out of this, we start with our numbers in this case. We have a 2. We have x squared on this side. Sorry about that. And we have just an x on this side. So common out of those is the x squared. And in both of them I have a y. That's my common denominator. All right. So then, now we move to multiplying each piece by the missing factor. So in this one, I have 3y plus 4. And the factor that's missing here, it has an x squared, which is right here. It has the y, but it doesn't have the 2. So I'm going to times it by 2. Plus, which is my middle process here, I have x minus 1. And what is this one missing? It has the 2, has the y, but it only has one x. So I'm going to times this one by x. Now I have to simplify. So we have 2 times 3y, which is 6y. 2 times 4, which is 8. Plus x times x, which is x squared. And x times negative 1, which is negative x. All over our common denominator of 2x squared y. And of course, we need to put that in the right order. So in this case, I'm going to start with my x squared on top. Negative x would go next. And then I have a 6y and plus 8. All over 2x squared y. Does anybody know why I put the x term before the y term? Remember, we like to write them alphabetical. All right, let's move on to example number 4. Okay, so we have 3x over x squared minus 16 plus 2 over x plus 4. All right, so the first thing we do is factor everywhere. This denominator can factor. It is the difference of squares. It is x plus 4, and it is x minus 4. Again, I'm going to cross this out because I've factored it. Talk about our restrictions. X cannot equal. In this case, x cannot equal negative 4. In this one, x cannot equal positive 4. And in this one, x cannot equal negative 4, which we already have. All right, so we stated our restrictions. Now we look for the common denominator. What I recommend is that you write down whatever factor is repeated in both. So both fractions have the factor x plus 4. So I have included this one and this one in my common denominator. The only one that's not included yet is this one. So I have x minus 4. That's my common denominator. Now everything has been included. All right, so next step, we multiply the top by its missing factor. Is this one, this first fraction, missing either of those factors in the denominator? It's not, so I just write down 3x. My middle process is plus. Over here I have a 2. And what one is this one missing? It has the x plus 4, but it doesn't have the x minus 4. So I have to multiply the top by x minus 4. All right, so let's go ahead and simplify. We have 3x plus 2 times x, which is 2x, 2 times negative 4, which is negative 8, over our x plus 4 times x minus 4. And on the top, combining like terms, we have 5x minus 8 over our common denominator, x plus 4 and x minus 4. And I am totally okay with you leaving it in factored form. Again, it includes these restrictions. All right, example number 5. We have y over 3y, plus 6 minus 5 times y plus 2. All right. So again, let's factor everywhere. This first one, we can undistribute something. In both of these, they have a 3 in common. If I undistribute 3, that leaves me with y plus 2. Cross this out. All right. State our restrictions. In the bottom, y cannot equal. First one, negative 2. And the second one is also negative 2. All right. Common denominator. What's in common is that factor of y plus 2. And then, of course, we also have a 3. All right. In the first one, I have y. Is this denominator missing either of those factors? It is not. So we just have y. The middle process is minus. Then I have 5. Which factor is this one missing? We have the y plus 2, but we don't have the 3. So we have to times by 3. So simplifying this, we have y. Negative 5 times 3 is negative 15 over the denominator of 3 times y plus 2. All right. They get just a touch harder. One more time. Last example for today. Here's example number 6. Example number 6, we have 5x over x squared minus x minus 6 plus 4 over x squared plus 4x plus 4. Alright, so the very first thing we need to do is, of course, factor everywhere. So let's start with this one. If I factor it, I have negative 6 on top, negative 1 on the bottom. My sides, of course, are negative 3 and positive 2. So I factor, I get x minus 3 times x plus 2. Cross that one out. Next one, let's factor over here. I have 4 on top, 4 on the bottom. My sides are 2 and 2. So I have x plus 2 times x plus 2. And I'm going to cross that out. All right, let's talk about our restrictions. Our restrictions, our x cannot equal. In the first one, what would make this 0 is a positive 3. What would make this one 0 is a negative 2. Over here, what makes this one 0 is also a negative 2. And this one as well. So our restrictions are 3 and negative 2. Now we look for our common denominator. All right, in our common denominator, we have x plus 2 in both. I'm going to include that one. So I've taken care of one of each of those. Now anything that's not repeated, I have to put in both of them. So I have an x minus 3, and I have this x plus 2, one more of them. All right. So on the top here, I have 5x. What factor is this 5x missing? It's got an x plus 2. It's got an x minus 3. But it doesn't have another x plus 2. Middle process is a positive 4 times by. This one's got the 2x plus 2's, but it doesn't have the x minus 3. Alright, so let's go ahead and distribute and collect like terms. 5x times x is 5x squared. 5x times 2 is 10x. Plus 4 times x is 4x. 4 times negative 3 is negative 12. All over x plus 2 times x minus 3 times x plus 2. And collecting my terms, I can put these two together. So my final answer here, I have 5x squared plus 14, sorry about that, x minus 12 all over. Now we can write them as 3 factors. We can write this as x plus 2, and there's 2 of them, so I can put squared, times by x minus 3. I could have left them all separate. And again, this has those restrictions where x cannot equal negative 2 and x cannot equal positive 3. So today's lesson, you are doing page 539. Numbers 11 through 21 all. The first couple have a common denominator already, just like the first couple examples we have. And then from there on out, they get a little bit tougher on each problem. Again, remember to factor everywhere and then multiply by the missing factors. All right, good luck, everybody. Remember that the odd problems are in the back of the book, so you can check and make sure you're doing them correctly. See you tomorrow. Have a great day.